In this video, we are going to have a look at trig graphs, which are also called circular functions. And just like a quadratic equation, when we first learned functions and quadratics, that had a general equation of y equals ax squared plus bx plus c, where a, b, and c were numbers which would change our quadratic. A trig function also has a general equation, and I've written it up here. It's a sine b of x minus c plus d. So this would be the general equation of a sine function. Now, I'm going to do an example, and as we do the example, we'll draw it and we'll talk about each of these four letters, where A is the amplitude, B is to do with how skinny or wide the function is, C is if the function has been shifted horizontally, and D vertically. So the example that we're going to sketch will be y equals 3 sine 2, then x minus pi on 4 plus, and let's use 4. Okay, firstly, what we need to look at is what our a value is, our amplitude. And our a for our function will be 3. And what that means is our function will go up and down 3 units from its midpoint. So if we have a function that looks like this, if we think about where its midpoint is, it will go up 3 and down 3 from its midpoint. And there's a formula to work out the amplitude if you're not given the original function. It would just be the total distance from the max to the min, or the min to the max, divided by 2. That'll give us our amplitude. So we know that's going to be 3 for our function. The next thing that I like to look at is the vertical shift, which in this case is 4. Now what that tells me is that our function will be shifted up 4 units, and because we have a sine functions start at their midpoint. If you have seen a sine function before, it looks like this, and a cos function starts at its max. So a cos would look something like this, slightly different. Okay, so our midpoint will be our starting point, which will be 4. So I'm just going to put here 4 on my y-axis. I'm going to put a dotted line across the screen. Now, if our amplitude is 3, that means that we're going to go up 3 and down 3 from our midpoint, which would be 4. So it's going to go up to 7 and down to 1. So let's put a 1 here and up to 7. And I like to put dotted lines here. And what these dotted lines will be is they'll be our train tracks. It's like our training wheels when we first learned to ride a bike. I like to do this when we first learned to sketch a circular function. Now, a sine function, it should start at its middle, but there has been a horizontal shift, which we will look at. But the third thing I do want to look at is this b value of 2. Now, this is to do with how skinny and wide our functions are, and there's a formula. The period of our circular function, and one period will be from when it starts to when it finishes and then starts repeating itself. That is one period. That is one period. The period of a trigonometric function, or a circular function, is 2 pi on b. So if we know b is 2, our period will be 2 pi on our b value, which was 2, which is pi. So what I then like to do is on my x-axis, I'm going to put pi somewhere. I'm just going to put it here for now. And double the distance, 2 pi. I'm going to draw the circular function twice. Now, once we know that, our trig functions have 4 key points. If you can kind of see this blue curve here, I'll put the 4 key points. Let's put in green. It's going to be up here at the max, when it comes back to its original, here at the min, and where it finishes. And obviously at the start is also important, but there's 4 main parts: the max, the mid, the min, then back to the mid. So what we know is that one period can be split into its 4 key points, and that's what I like to do on my x-axis. So if I have pi here, I'm just going to put pi on 2, therefore pi on 4, and here this will be 3 pi on 4. So there's a quarter of our total period, and we can continue that on. This is going to be 1 1/4, so 5 pi on 4 This will be 6 pi on 4, which is 3 pi on 2, then 7 pi on 4, and then 8 pi on 4, which is 2 pi. Okay, so as soon as I see this b value, I calculate the period and I split it up into 4. And then finally, I look at the horizontal shift. Now, minus pi on 4 inside the bracket means it's been shifted horizontally pi on 4 units to the right. If you remember your horizontal shifts, it's the opposite way to what you think. So I'm going to put in my first point. I know that a sine function should start at its middle, but because it's been shifted 4 units, pi on 4 units to the right, it's going to start here. Well, that's where a point that it will go through. Okay, a sine function then goes up. So with my train tracks, I know that I can go across to my next point, pi on 2, and go up to 7, and put a dot here. And then I'm going to continue this on. I'm going to go across, back down, and then across another. It's going to be to the min, then back to here, and then back up to here, here, and here. And then we do need to think about where our function will actually start, and it's going to be down here because of the horizontal shift. It shifted it all this way, so therefore this will be a point on our curve. Now once I have all of my dots, it's quite easy to draw a circular function. You want to put nice curves, and a way to do nice curves is to connect 3 dots here with a smiley face, and then, a frown face, and then a smiley face, and then a frown face, and then half a smiley, half a smiley. And that will be our function, 3 sine 2 of x minus pi on 4 plus 4. So the first time you do sketch these, it's a little bit tricky, but I think if you stick to this template of sketching, when you come to IB questions, they don't actually ask you to sketch very often. They'll give you the sketch and you need to find A, B, C, and D. But I think if you can sketch it, you can do the reverse a lot easier. You'll have the skills. You'll know what A, B, and C, and D actually mean. Okay, so in summary, we know that the amplitude is 3 because it goes up and down 3 units from its midpoint. The midpoint will be the vertical shift, which was 4. We then know that it's going to have a full period of pi because it's 2 pi on B. So we know that it's going to start and finish in pi units and then do the same thing depending on how long we want to draw it for. And the horizontal shift is important to know where our first dot will go, and then we can just connect all of our dots. Okay, I encourage you to practice a few of these questions, so good luck.